All right, just calculate our net force and acceleration of this object. Once again, we have a force applied, but what now is occurring, rather than,
Oh, we haven't changed that.
why?
It was the same
It's
problem
the
we did
same
yesterday.
problem. I mean, I can't, I'll do
Relax.
it. Okay.
Rather than pulling this mass along like a puppy dog, if you look at the arrow, we are now pushing down on this mass and pushing from behind.
I didn't drop that.
It's amazing if we just are a little patient, what would occur. But we are now pushing down. So is it the same problem? Is it the same problem? No, it's not the same problem. So what we have is if we resolve our forces, we now have this. We have pushing down. Rather than resolving our forces and pulling up on this and sideways, we're pushing down on it. So we are pushing from behind. We still have our force of gravity. Which is 20 times our 9.81, which is 196.2 newtons, is our force of gravity downwards. But now if we take a look at resolving our two forces, we now have 24 newtons here, and we have 48 cosine of 30 here, which will still give us the same amount of what we had up above, 41.6 newtons. Now, what's the difference going to be with this problem?
Instead of a force that's acting on the object going down or going up, it's going down.
So what's going to change from what we had to do before?
The force of friction.
Before the force of friction, what will change?
Force normal.
The force normal. Because now we have our force of gravity, but we also have another 24 newtons that are basically pushing down on this object. So our force normal is what is the force between the floor and the object. What do we have to do with the two forces now? 24 and the 196.2.
Add up.
Add that. So our force normal is 24 plus the 196.2 newtons. So we have 220.2 newtons is your force normal. So now we can calculate our force of friction is mu times force normal. So we have 0.18 times 220.2. What's our force of friction? 39.64 newtons is our force of friction. Look at that. Okay, so once again, we are now pushing down on this object. So we are hoping that we're going to get motion in this direction, which means our force of friction is going to be counter of that. So our force of friction is 39.640. Our force net, well, we have 41.6 newtons here, 39.64 newtons here. So we're barely able to overcome the force of friction here. So we're right around 2 newtons, 1.96 newtons. Is our force net, so we can add mass times acceleration. So we can divide by our mass, which is 20 by 20. So our acceleration is not very large. A little over 1.1. 0.11. 0.098. Out of the way. Meters per second squared. Calculate the net force and the acceleration of the object. Now, once again, we have a pulley system here. We have 10 kilograms up here. We have 2 kilograms here that's hopefully pulling this down. We'll see. Our force of gravity, which is our weight. We have 2 times 9.81. 19.6 newtons. That's our force of gravity. That's pulling it down, but it's also what is experienced right here. So we are pulling at 109 or 19.62 newtons. We have hopefully motion going in that direction. That's if we can overcome friction here. If we can't overcome friction, we don't have motion. This object here is not going to start pulling it back. So we can calculate our force of friction. So calculate your force of friction. Which is mu times force normal. So we have to calculate our force normal. We have force of gravity, its weight is 98.1 newtons. Do I have to throw anything else in with that? No. So this will be my force normal also. Because all we have to do is we have to keep equilibrium up here. This has nothing to do with the force normal. 2 kilograms over here has nothing to do with this force normal. Force normal is counteracting your weight, your resistance force, basically. whatever your resistance force is, okay, that's your force normal. You're counteracting that. Okay, so I need to make sure I have enough strength here to take care of 98.1 newtons. So our force of friction is 0.1 times 98.1, which takes us back to 9.81 newtons. Okay, so that is my force of friction. So my 19.62, my force of friction is 9.81. We have enough to overcome it. So our force net is equal to our force applied plus our force of friction. Force of friction is negative. We subtract off 9.81 and we come back to 9.81. This is equal to mass times acceleration. So to find our acceleration, what are we going to have to divide by?
12.
12. Because we have, once again, both of these masses are moving. Both of these masses are moving, so we have to deal with the total mass. So our total mass that is moving here is 12 kilograms. So we can divide both sides by 12. We have 9.81 divided by 12, which gives us an acceleration of what?
0.82 meters per second squared.
0.82 meters per second squared. Once again, details, little details. Okay, you should start to get used to when I have a combined system, my total mass. I have to deal with my total mass here. Okay, but you're still looking at, you know, how do I deal with my force normal? Okay, you have different scenarios that could happen with your force normal. Here, this is going to increase your force normal. This up here decreases because you're pulling upwards. And this 24 newtons. And this first one, since we're pulling upwards, we're pulling up at 24 newtons. So we have to decrease whatever our weight is here. Okay, so these are the different types of scenarios that we will work on and continue to go through. I'm going to stop there today. So tomorrow we'll have a few more people here. We'll start working with the inclined planes. We'll start inclining the plane a little bit now and start working with that. Once again, it's like what we're doing in calculus right now. It's that one extra thing we're going to add into it. You know, we've dealt with the chain rule in calculus. Now we added additional trig functions that we can use and apply your chain rule to. So it's a combination of continue to add on to what we've been doing. The inclined plane is the addition to that. All right. I have nothing else for us then.